Hello viewers, welcome to my channel Learning with Khatak. Um, After performing bivariate analysis, univariate analysis and multivariate analysis, finally we are at the stage to start building a model in order to train this model and then predict by inputting some data that whether the patients have a heart disease or not. So we have developed so far the three parts. Part 1. In part 1, we have performed bivariate analysis on our datasets. We explore our datasets. We look into our datasets that what are the features inside the datasets. We preview some records, and then in part 2 we perform the bivariate analysis by comparing the relationship of different features with our target variables. There we also look the null values in the data sets. Luckily we don't have any columns having a null values, and then we perform different operations by knowing the data types of the columns, the null values, null or non values, and then shapes, and then target variables, and then different variables, and then perform analysis on different features. In the third part, we performed the multivariate analysis by generating a heat map, very important part by developing any model is to generate a heat map to show the relationship, the correlation between the dependent variable that is a target and independent variables that is the rest of the features. So after performing the extensive analysis on our patient data sets, now we are here to start building our model. We have clean our data, we have prepared our data for our model. Now there are different steps to develop the models. Basically, we have a data sets having more than 300 records. Uh, how to train our model? First questions, how to fit our model on the training data sets, and then how to predict. So these are the three steps, basically four steps: dividing the data sets into training and testing sets, and then creating the model, and then fitting the models, and then predicting. And the fifth one is by giving some random inputs to show the accuracy of your model. So let's start that how to train that how to divide our data sets into train test splits. In the last part, yes, this is the multivariate parts. Okay, so let's start our uh, dividing the data sets into train and test sets. As we know that we have more than 300 of record in our data sets. First, I'm going to import from sklearn.model selection. I'm going to import a train test split library, train test split module, which will be used to divide our data sets into respective training and testing sets. So if I run this code, it gave me okay. Here I did not perform any thing extraordinary. Here in this case, first we need to divide our data sets into features, that is X. If you look at this, features, and then target. And this is, let me explain the parameters: features, target, test size, random. So test size, what I have performed, I divided my data sets into two parts, that is training and testing, in the ratio of 80-20. 80% is my training part and 20% data will be remained for the testing purpose. So we need to divide our data set into features and labels, that is target. What are the features and what are the labels? The features will be labeled to the respective target. the data frame here in this case, if you look at the data frame or data frame features and target or respective in all data frames there are two things, that is features and targets. First we create an object of features by dropping the target variable and putting all other features in the features, and similarly target in the data frame, and basically data frame have the data sets. So from data sets the target values will be pasted here in target. Here the target will be dropped and rest of the features will be placed here in features. Okay, the data frame get divided into X train, X test, and Y train and Y test respectively. So X train and Y train sets are used for training and fitting the models. Later on we will see that X train and Y train will be used to train and fit our model. The X test and Y test are used for testing the model if it is predicting the right output or not. For example, to predict the class label, that is the target. So we can explicitly test the size of the train and test it. It is suggested to keep our train set larger than test set. Here in this case, our train set is 80 and test set is 20. So here we have divided our data sets into two parts, that is training and testing, and then we want to show that how many samples are there in the training set. Keep in mind we have total 303 samples. So now in training there are 13 features and 242 samples for training. So we will train our model using 242 samples or record, while rest of the record will be used for the testing purpose. Similarly, if we want to know that how many samples will be there for testing our models, that is 61 models, so 61 record. So 61 samples will be there to test our model, while we will train our model using 242 samples with 13 features. Similarly 61 samples with 13 features will be used to test our model. Okay, similarly if we want to know the Y training model, this is basically the X training. Similarly, if we want to know the Y training shape, again 242 242. Keep in mind X contains features and Y contains the target value, the target label or the class label. So means we are going to train our model using 242 samples records. In Y train we have 242 target values. Okay, similarly that is Y train, and similarly if we look at the Y shape, Y test shape, 61 samples or target values will be there in Y test data sets and our sets to predict whether the input is correctly predicted or not. Okay, now let me summarize this. Now Y actually contains target and X contain other than features other than the target. If I simply print this, 303 records are inside the Y, 303 and 13 are inside the X, that is basically contains the training data. So summary of train test set, this is the summary. If I run this, shape of X train. So basically we have divided our data sets into four sets, that is training data sets or training data sets. Yeah, our training set consists of 242 samples with 13 features. Shape of Y train, that is basically contains the target labels, that is 242. Shape of X test, that will be tested. This data will be used for testing purpose, and that will be used to show that whether the tested data is predicted correctly or not. So in first part, we have divided our data sets into respective train test sets, and then uh, we look at the different data inside the train set, test set, X train and X sets. Okay. So fitting model. So what type of model we want to build, or what type of model is used to predict the data? For this I need some libraries. These are different libraries for classification report, for confusion matrix, accuracy, and then trend split, etc. I simply run this. Okay. Now, logistic regression model. I want to deploy logistic regression model on the data sets. On which type of data sets? On training data sets. Or in other words, I want to train logistic regression model by using my train set data. So if you look at this, I'm going to simply, what I have did here, from sklearn linear model import logistic regressions, I simply import a logistic regression models. There I created an object of logistic regressions, and then I fit this model. LR is the logistic regression object or model. Here in this case, this model is fit or via X train and Y train. And X train, if you look at the data in the X train, shape of X train 242 with 13 features, means I am going to train the logistic model LR with how many samples? With 242. And similarly Y train will be 242, 24 Y train 242. So what does actually means? That this mod we supplied 242 samples with their respective class labels. Y train contains the class labels and X trains are the samples are used to train the models. How to train the models? X train and Y train, and here we are going to predict Y predict LR. So this is the object, just like a variable, and then the model is going to predict by using the predict method. While on X test, if we look at the data and X test, X test contains 61 and 13. We want to test that here when we train our model, that how the training is of our respective models by testing this model here in this case. So I simply run this code. This code gave me nothing because I did not display the accuracy or something else. Now the if I print the accuracy shape 61, if you look at this code, X test, I simply told that we are going to predict by giving 61 different type of records to the model. That's how he predicts based on the training he get from this steps, from step number second. So 61 is the predicting samples. Now to check the accuracy, that whether our model is correctly predicted or not, I need some libraries. Okay, I simply run this, and then the accuracy. score simple an object are variable. Round accuracy score, for accuracy score I passed y pread, this is basically 61, and then y test. And y test, if you look at the y test shape, I there is white 61 target variable, 61 target variable. So I provide here in this case, if you look at this, 61 and 61 target variables and 61 testing variables to know the accuracy of our model. So if you look at this, the accuracy score achieved using logistic regression is 85.25. So good, it's not bad. Now the main question is that when we're reading some research paper or we are listening from someone that my model is accurate up to 90%, 95%. There are several features, several aspects that depends upon the accuracy of the models. How your data is clean, have you used any hypertunings, have you hypertuning parameters, have you used any data sampling techniques, or something else, we will discuss them in later on. So similarly, if I want to print the confusion matrix or classification reports of this model, I'll simply print matrix dot confusion matrix y pread y test. I'm provided two values from there. If I print this, this is the confusion matrix, and this is the precision value, this is recall, and this is F1 score, and this is support. Similarly, a classification report is accuracy, micro average, and weighted average. So these are the output or classification report of my regression model. Similarly, if I want to train Navy Bayes model NB by using the same patching data sets, I just provide, I have simply create a model from Gaussian NB, then fit the model on training, and then predict. Similarly, if I use here the prediction shape, again 61. So if I want to print the accuracy of the NB model, that how it's accurate, again simple round accuracy score. I am providing two things, y pread and y test. You can check the values of y pread, that how many values are in y pread and how many values are in y test. We also explained the nature of these values, that what does it mean is by y pread and y test, and this is for just the percentage. And if I run this, okay, score NB. So the accuracy score achieved using Navy Bayes is 85.25, almost same. Similarly, if I look at the classification report or confusion matrix, so this is the confusion matrix, precision, recall, F1 score, and so on. Similarly, now I want to train a support vector machine, very important classifiers. So same four steps: creating the objects, fitting, and then predicting. So here I train my model. If I run this code, I'm going to train my model and fit my model to predict. The prediction shape is now here in this case 61. So if I want to the accuracy, here is simply the accuracy by again providing y pread and y test. SVM, 81.97 is the prediction rate, is the accuracy score of the SVM. Again, by following the above steps, you can also look at the classification report and confusion matrix. Okay. Similarly, we can also train the KNN classifiers, the same four steps here, creating objects and then train the objects or model, and then predict the model y shapes predictions, that is again 61. And again the accuracy, so the accuracy of KNN is 67.21. Okay, let me train to other models, that is decision tree. In decision tree, basically we have a maximum accuracy 0, import decision tree, and then because a decision tree is actually creating multiple number of trees to train the model. Obviously that will we will explain in a separate lectures the working mechanism of decision tree. Here I'm just concerned with the accuracy. So if I simply the wipe read, okay, 61, and then the accuracy, and this is the accuracy. If we run this, 81.97. So the last one is, I think, random forest. Random forest is very important in symbol classifiers. So this is just leave this code. Okay, so this is I'm going to run this, and sklearn y breed shapes, and then I just want to see the accuracy. So this is the accuracy, 86.89, the maximum accuracy I think so far. So this is the part number 4, where we have divided our data sets into respective train test sets, and then we look into the shapes of training data sets, training set, testing sets, and so on. So we have trained 5 different models. In the next part, we will compare, we will put the results of each training models into a file, and then compare the each model with respect to their accuracy and classification reports. And obviously an important part will be covered, and important discussions will be covered in next part, that is how to give inputs to our models. We will take data of a patients and then supply it to our respective models to show that whether the patient has a heart disease or not. So for the time being, thank you very much. Hopefully we'll be there with part 5 to actually take some input data of patients, and then using our trained model to predict whether the patients have heart disease or not. Thank you very much.